And the graphs of tangent and cotangent can be thought of together. First off, what makes them unique? Their period is 180. It's the only ones that doesn't have a period of 360. They have a period of 180. And basically, when you are going to graph y equals tangent or cotangent, anytime you have a 45-degree angle or some version of a 45-degree angle, like 135 or 225, tangent and cotangent are what values? 1 and -1. Because sine and cosine are the same, right, at 45 degrees. And so since tangent and cotangent are sine over cosine and cosine over sine, then the easiest thing to graph with regards to tangent and cotangent is to put in the 45-degree angles. So if you just know where to put in your 45-degree angles, you can probably do a pretty good job of remembering how to graph these two. Tangent is sine over cosine, and cotangent is cosine over sine. Everybody remember this phrase right here? All students take calculus. What does this mean? It means in quadrant 1, all 6 trig functions are positive. So it means all positive. When in doubt, assume you're in quadrant 1. The S for students stands for sine. It tells you that sine and sine's reciprocal cosecant are positive in that quadrant. Everything else is negative. Take is for tangent. It basically says that tangent and cotangent are positive in that quadrant. And everything else is negative. And the calculus stands for cosine. It says that cosine and secant are positive in those quadrants, and everybody else is negative, right? So, if we were going to graph tangent, we know tangent at 45 degrees is positive 1. We also know that cotangent at 45 degrees is positive 1. And the most confusing thing to me about tangent and cotangent, what graph does it remind you of from last year? Y equals x cubed, yeah. Some people say it's an S. No, it's not really an S, but it reminds you of y equals x cubed, right? And if you just remember where they're 0 and where they're undefined, you're really going to be just fine. So, what is tangent at 0 degrees? Since that ordered pair is 1, 0, right? Tangent is sine over cosine. So what's tangent at 0? 0. That means tangent has an asymptote at 90. That means that cotangent has its asymptote at 0, because it's the exact opposite. That means that it's 0 at 90. And that's really kind of enough to see what these graphs look like. This side goes up. That means that on the other side, it's going to go down. And there's going to be another asymptote right here. Make sense? Just think of tangent and cotangent as sine over cosine. And then think about when sine 0, that's when tangent 0. When's cosine 0, that's when tangent's undefined. When's cosine 0, cotangent 0. When a sine's 0, that's where cotangent's undefined. And so this one goes up like this, and then comes down like this, and has another asymptote here. Domain and range of tangent and cotangent. What's the easier thing? The range. What's the range of both of these? All real numbers. That also means the tangent and cotangent, as well actually as secant and cosecant, have no what? Amplitude. Because what's amplitude? The highest point. What are the only two functions with amplitude? Sine and cosine. Secant has no amplitude, it has no highest point. The arrows keep going up. Cosecant has no amplitude. Same thing with tangent and cotangent. They have no amplitude because the amplitude is the highest point. For the domain for tangent is all real numbers except x is not equal to, and you can basically see where the asymptotes are, so 90 plus 180n. And then when you do cotangent, the range again is all real numbers, and this time the domain is x is not equal to, and you can see it there, 0 plus 180n.